Dear students, in this session, we will discuss the solution of the problem where our language L is of the form WWR. Means a word W is coming and then its reverse is coming. So basically it is a palindrome. Where this W belongs to A, B asterisk means our palindrome, our words are formed from the two symbols A and B. Okay, and these are all the even length palindromes. There is no odd length palindrome is possible. It is similar to the problem which we have discussed on the last session, that was WCWR, where W belongs to A, B asterisk. So our palindromes, here also we are having the palindromes, but all the palindromes will be of the odd length because W and then WR is repeating, so they are reverse of each other, and then C is coming in between as the separating marker. So always the length in this language which we are having for the palindrome is of the odd length, and C was always the marker which is marking the end of W and the start of WR. So this was the benefit available in this language. We can easily identify that where W is finishing and WR is starting. While in this current problem, we have this difficulty how we will be marking that W has finished and WR has started, because W and WR both are made up of two symbols only, that is A and B. So where to mark and this we have to decide. Here we are having the knowledge, whenever C comes we have to start, we have to stop pushing because W has finished, and then we have to start matching. Here we will be having a confusion up till when we have to push and from where we have to start matching. Now we have understood the difference between the previous problem and the current problem, and how our current problem is difficult than the previous problem. Okay, so let us start the solution of this current problem. Again, the strategy is same. When we are reading W, we have to push. Okay, so first letter in the word of this language will always has to be pushed, as we have discussed that our words will always be of the even length. Okay, so it cannot be of the odd length. So first letter should always be pushed. So whether the first letter is A or B, it has to be pushed. So over this condition, delta Q0 AZ0, it represents the initial situation. We are in the start state Q0, and at the push down store there is the start symbol, that is the Z0, the start push down start symbol. Okay, and similarly the second one is also, it depicts the situation when we are in the initial position Q0 Z0, but in the input the first symbol, the first letter is B. So either we get as the first letter A or B, we have to push it. So we are pushing it Q0 A Z0 and then Q0 B Z0. So using either of these two transitions, we will be pushing our first symbol in the input string. Now we will come on to the next symbols. When we come on to the next symbols, then we have to decide whether these symbols we have to push or we have to start matching. So if our W has end here, then we have to start matching. If our W has is still continuing, then we have to continue with the push. Now how do we decide whether W has finished here or not? Let us assume any word in this language. Suppose the word is A, B, A, B, A. Suppose like this. Obviously, this is the middle portion, and this symbol is A, and this symbol is also A. Okay. Let us take another example. Suppose this is A. Suppose this is the word. This will be a word in the language, and this is the middle marker. So our W finishes here and our WR starts from here. Okay, let us take some other example. Suppose AB, middle marker is here. Sorry, this is not a word in the language. So I have to write AB, B, A. So this will be a word in the language, and certainly this is the middle marker, and we can see that the last letter of this word is W, this word W is B, and the initial of WR is also B. So wherever our W is ending, we can observe that we will be having the last symbol read as the same symbol as the current one. Okay, So whatsoever is the last symbol read, the same symbol we will be getting as the current symbol. So meaning thereby, wherever the same symbol is occurring, then there is a possibility, yes, from there our W may end and WR may start. So in such a situation, we have to start matching. But it is not necessary. Suppose I take another example. Suppose the example is A, B, B, A. Suppose this is my word. So this is the middle marker and my W is this and this is my WR. Okay. So, but whenever I read an A and I again read an A, so there is a possibility, yes, my W has finished here and WR has started, but it is not the actual situation. So, meaning thereby, whenever I am reading the same symbol, I have to decide whether it is the actual end of the W or not. Whether we have, if it is actual end of W, like this is the situation, then I have to stop pushing and start matching. But suppose if it is such a situation when there is a possibility that W has end, but W has not actually end. So I have to continue reading the W, so I have to continue with the push operation. So this I have to decide. So these two operations simultaneously I have to take in this situation when I am reading the same symbols in continuation. So this will be the strategy. So as per this strategy, we will be designing our transitions. So let us come. So when we have pushed our first symbol, whether it is A or B, so on the top of the push down store, either there will be the symbol A or there will be the symbol B. Okay. When there is a symbol A in the as the next input, I can get either the symbol A in the input or the symbol B in the input. So these are the possibilities. Similarly, if B is at the top of the stack, then either A or B I can get in the input. Okay. So if the situation is Q0AA, so now here what I am getting, the last symbol read was also A because it is on the push down top of the push down store. Now current symbol is also A. So same symbol I am getting in the continuation. So it may be the end of W or it may not be the end of W. So I have to take the action corresponding to both. So if it is not the end of W, then I have to push. So if I will be pushing, I will remain in the same state and I will be pushing it. So I will be writing AA. So this is first action which I will be taking in this situation. Now the second action is, suppose W is ending here and WR is starting. So in that case, I have to match these two A's. I have to start matching. So if I have to start matching, I will move to the another state Q1 because my operation is changing from pushing, I am changing to the matching. So Q1, and because I am matching, so I have to write null so that topmost push down store symbol is erased and the current input symbol A is matched with the topmost symbol which is stored over the push down store. So this will be the action. So I will change the state and I will write a null here. So if my W is not ending, I will push. If my W is ending, I will match. Okay. So these two actions I will take. So actually this is our first example in which explicitly I have made use of the non-deterministic nature of the PDA. Now come on the next situation when Q0BA means last symbol read was A that is on the top of the push down store and the current symbol is B. So if this is the situation, so there is a clear-cut indication that W cannot end here. Okay, so means W is continuing. I have to simply push. So I will be writing Q0BA. So in this manner, I will be pushing my input B, which I am getting from the input, so that I will be pushing over the push down store. And similarly, in this situation Q0AB, simply I have to push. There is no question that W is ending here and we have to start matching. Now come on the next situation, that is Q0BB. Yes, again there is a situation means last symbol read was also B, that is on the top of the push down store, and the current symbol is also B. Okay, so here is the possibility. So first possibility is that we have to push, so we will be pushing, and the second possibility is that we have to start matching. So we have to match, so we'll change the state to Q1 and we'll write null so that the symbol B present on the top of push down store and in the current input will match. Okay, so these will be the transitions. Now we have seen that through these two transitions, we have pushed our first symbol of W, and then through these next 4 transitions, we are continuing the pushing if W is continued, and whenever we have the situation where W may end, we are also taking the action that we will start matching. Suppose W is continuing, then we will always be in the state Q0 and using any of these 4 transitions. But whenever we will move to the state Q1, okay, so it means W has ended and we are starting the matching. Okay, so there will be the situation Q1, and then on the top of push down store there will either be an A or there will be an B. Then in what situation we can get success? If on the top of push down store is A, means next symbol in the input should also be A. Only then we can guarantee yes, we are successfully going with our word. Our word is actually a palindrome. Okay, if B is occurring, then then we have to reject the word at that point only. Okay, so we are not writing the transitions corresponding to those, so that in those situations our machine will halt and string will be rejected. So Q1 AA we have to match. So we will remain in the state Q1 and we will write null. So we are doing this matching, and then in the situation Q1 BB also we are doing the matching. Okay, so suppose continuing with these 2 transitions, our word has successfully matched. Means all the symbols other than Z0 has been popped from the push down store, and in the input our input has also exhausted. If such a situation is there, means at the end of our input we have popped all the elements whatsoever we have pushed over the push down store. So meaning thereby we will be in the state Q1, and on the top of push down store there will be Z0, and our input has exhausted, so we have no other option but to take the null move. So we'll take that null move and we will signal the success. So we'll be writing it Q1 null. So we'll empty our store and we will signal the success. So in this manner, this is the solution. Now there is one more situation left. That situation is because W can be empty as well. So if W is empty, so WR will also be empty. Its reverse will also be empty, null string. Okay, and null string will be the null string. So meaning thereby this language also contains the null string. So initial situation we have taken only towards the condition when we are actually having some symbols into the input string. Okay, so corresponding to A we have written transition, corresponding to B we have written transition, but we have not considered if null is also present in the language. So if null is also present in the language, so in the state when we are having the Q0 and Z0 on the top of push down store, we have to write that transition corresponding to the null as well. Okay, so now we are writing that transition. Suppose there is the situation Q0, input string has only the null and it is Z0, so it should also be accepted. So we should accept it. So we should accept it only by emptying the push down store. So we will remove this Z0 and our push down store is empty. So our machine will halt, but also our string has ended. So null will also be accepted over this machine. So this is the complete solution for this particular problem. The difference in this problem, as we have already discussed, is that we were not having the separator where W is ending and WR is starting. So that we are doing by making a guess in the situation when W may actually end. So if W is ending, then we are starting with the matching. If W is not ending, then we are continuing with the push operation. And as we have discussed in case of NFA also, how they execute in such a situation, they take all the possibilities. They create the threads corresponding to the different actions which are to be taken. So basically, whenever we come to such a situation when the previous symbol is also A and current symbol is also A, so in one thread, our machine will push the A and continue with the execution. In other thread, our machine will start matching. It will remove the topmost PDA push down store symbol, go to the state Q1 and continue with the further execution. So some of the threads will give you the failure and some of the threads may give you the success. If any thread is giving you the success, then your string is successful. We have to ignore all the failures and we have to take the success as we were doing in the case of non-deterministic finite automatons. Now let us come to our next problem, that is L is equal to all words W belonging to A comma B asterisk such that NAW is equal to NBW, meaning thereby our language will consist of all words W which will be formed over A and B, where the number of A's in word W and the number of B's in word W are equal. Okay, so all words where number of A's and number of B's are in equal number, so all such words will be accepted in this language. So let us take one example to understand what should be the strategy for solving or for writing the transition for this particular problem. Let us take this example. Suppose this is our word W. So here it is A, single B, then A, then B, some number of times, and then A. So we can see here number of A's are equal to number of B's, 1, 2, 3, 4, 5 and 6 A's, and similarly B's, if we count 1, 2, 3, 4, 5 and 6 B's are there. Okay. So one strategy may be that whenever we have A's, we will push it. Okay. Or if our word may also start with B. So if word start with a B, we should push it because we have to match the numbers. Okay. So A we are getting, we will push. So first A, it is pushed. Then second A, it is pushed. Then third A, it is pushed. Meaning thereby, whenever we are always first symbol we have to push, whether it is A or B. And if we are getting the same symbol which is already on the push down store, then we will also push. So here we are having A as the first symbol, so we have pushed, and then we are having A as the topmost push down store symbol. So second A is also coming, so we have pushed it. Now again we are having at the top of push down store A, we are getting A, so we will push it. And whenever we find a different symbol, that is suppose at this fourth position we are getting a B, then we will match. Okay, because corresponding to A's we have got one B. So whenever we will have this B, we will pop the topmost symbol which is A from the push down store. So now we are having two A's. So this strategy will always tell us how many number of symbols are remaining to be matched and which symbol. So in this case, suppose A's were more up till now, number of A's were more, so A's will be on the push down store. But if the situation is reversed, suppose in place of A's we write B's, or in place of B's we write A's, then the situation will be reversed. Then the more number of B's will be there and B's will be stored over the push down store. Okay, so we have come up till now. Now again we are getting A, and at the top of push down store we are having A, so we will push it. Okay, then we are getting B, so next B we have got, so we will remove one symbol from the push down store, that is it has been matched. Then next B, it is matched with the topmost push down store symbol A. Then next B, it is also matched with the topmost push down store symbol A, and then we are getting B. So now at this position we are having only the Z0 at our topmost symbol on the push down store, so no A, no B. So in this situation, whatsoever A symbol A or B is coming, that we have to push. So now we are getting a B, so we will push this B. So we have pushed this B. Okay, then again the next symbol B has come, and B is also on the push down store, so it will be pushed. Then we are getting A, which is the opposite symbol or different symbol, so we will pop. Again we are getting next A, then we will pop, and ultimately when string is finishing, we are having only the Z0 at the top of the push down store. So in this situation we will signal the success. If there is any symbol left, either A or B, then it means our string does not contain equal number of A's and B's. If we are containing some number of B's here, it means our string contains more number of B's. If we are containing certain A's here, it means that our string is containing more number of A's there. If they are equal in number, ultimately we will left with Z0 only. So this will be our strategy, and according to this strategy we will be writing our transitions. Now as per our discussed strategy, we are initially in the state Q0, and Z0 will be on the top of push down store, and as the first letter in the input, we can either get A or we can get B. In both the situations we have to push. If we are getting first letter as A, then A has to be pushed. If we are getting first letter as B, then B has to be pushed. Okay, so whatsoever symbol we will get, whenever Z0 is on the top of position store, we have to push it. Okay, because this condition, when we are in the state Q0 and topmost symbol is Z0, it reflects the situation when number of A's and number of B's are equal. Initially, both number of A's and number of B's are 0. So that's why whatsoever symbol, whether A or B, we will get, we will push it. Now, after pushing the first letter, there may be the situation either A is on the top of the push down store or B is on the top of the push down store. If A is on the top of the push down store and we are receiving the same symbol in the input as well, then we have to push, because number of A's are more and we have to push the A's to keep a count that how many A's has come. Okay, so that's why if the same symbol is we are getting, we will be pushing it. And similar is the situation when B is on the top of the push down store and we are getting the B in the input as well. So same symbol we are getting. So being B on the top of push down store means that number of B's are more, and so whatsoever B's we are getting from the input, we will push to keep a count how many B's extra has come. Okay, so this will be the pushing operation. Now come on the similar situation when A is on the top of the push down store, but in the input we are getting B means a different letter. So when a different letter we are getting, then we have to match and we have to remove this topmost push down store symbol. So we will remove this topmost push down store symbol by writing null to it. And similar is the situation when B is on the top, but in the input we are getting A. So we will match, we will write null over the push down store to remove this topmost symbol B. So in this manner we are doing the matching. Now one difference from our all previous discussion is that up till now here we were pushing, we are doing the operation of pushing, but in this situation we are doing the operation of matching, but even then we have not changed our state. Okay, we have not changed our state. So this is a special example where we have not followed the guideline. As I have told you initially that those are only the guidelines. So whenever operation changes, we have to change our state, but it is not mandatory. So this is one example where we have not followed that guideline because it is not required. It is not, if we change the state here, then we will be coming with more number of states and these states will keep on expanding. Okay, we will not be able to write a proper solution for it. So we can write a better solution without changing the state. So that's why we will be following it. So this is the example where we have violated the guidelines as well. Okay, so this is the example. So we will keep on using these 4 transitions to match wherever match is possible and to push wherever push is required. So in this situation, when same symbol we are getting, we will keep on pushing. When different symbols we are getting, we will minus the number of symbols from the top of the push down store. So in this manner, our push down store, that is the stack, will keep on growing and shrinking. And after doing all these processes, after processing the whole string, if suppose ultimately our push down store becomes empty, not empty, but there will be Z0 on the top of the push down store, because we are always removing either A or B from the top of the push down store. Never we are removing the Z0. So Z0 will always be there. So if only Z0 is present on the top of the push down store and our whole string has been processed, so this is the signal of success. So in such situation, when we are in the state Q0, because never we have changed the state, we are always since the starting at the state Q0. So we are in the state Q0. Our input string has exhausted, so we are taking only the null move from there. And on the top of push down store, there is Z0. So in such a situation, we will signal the success by emptying or by removing this Z0 as well. So we will make our store empty and we will signal the success. So in this manner, we will solve this particular problem. Now I wish that on the basis of discussion which we just had, you try to solve certain problems at home at your own. These problems are that first language L is all words W belonging to A comma B asterisk such that NAW is greater than NBW. So meaning thereby our language should accept all words over A and B where the number of A's is greater than number of B's. So this is the first problem. Then second problem is the same one. It will consist of all words W over A and B such that number of A's in W is less than the number of B's in W. So here in first problem we want number of A's should be greater than number of B's. In this second problem we want that number of A's should be less than the number of B's. And the third problem is where number of A's are not equal to number of B's. So we have discussed one problem where number of A's was equal to number of B's, and I want that these three problems you try to solve at home at your own. Thank you all.